created by MindSticks Foundation Trust.
Hello, and welcome to this explainer. Today, we are going to go on a step-by-step journey to completely master two very important concepts for grouped data, the median and the mode. Our agenda is beautifully simple. We will start by demystifying the median formula, then we will actually solve for the median. After that, we will understand the mode formula, solve for the mode, and finally set aside some time for your practice. Let us dive straight into this.
Section 1. Demystifying the median formula, finding the middle ground. Now, I know that statistical formulas can sometimes look a bit intimidating. You see all those letters and brackets, and it feels a bit much, but please do not worry at all. We are going to conquer this abstract math together very patiently. Before we look at any complex formulas, let us ground ourselves in plain, simple English. What exactly are we looking for? The median is simply the approximate middle score in a given frequency distribution when all the data is arranged in order. Just imagine lining up all your data points from the smallest to the largest. The median is that perfectly balanced point right there in the middle.
Now, please observe this table carefully. It shows the daily distance traveled by 60 public transport buses. Look very closely at the classes in the top row. We have 200 to 209, and then the very next class starts at 210. Do you see that gap between 209 and 210? This is a major trap. It catches so many students during exams. The classes in this table are not continuous.
And here is the crucial point. We absolutely cannot use our median formula on discontinuous classes. But fixing it is actually quite brilliant and simple. We take that gap of 1 and we divide it by 2, which gives us 0.5. Then we follow a strict, non-negotiable step. We subtract 0.5 from the lower limit and add 0.5 to the upper limit. So 200 to 209 instantly becomes a continuous 199.5 to 209.5. This seamlessly bridges the gaps between all our classes.
To ensure you never get confused, here is our clear, reliable 3-step recipe. Step 1. Always check and make your classes continuous. Step 2. Create a less than cumulative frequency column by keeping a running total of your frequencies. And Step 3. Find n divided by 2, where n is your total frequency. This magical number helps you precisely locate the median class. We absolutely must set up our table exactly this way before we even attempt to touch the main mathematical formula.
And speaking of the formula, here are the ingredients we need to collect. Let us patiently isolate what each letter represents so it transforms from a scary equation into a simple fill-in-the-blanks exercise. L is the lower class limit of our chosen median class. H is the class interval, basically the size of the class. CF is the cumulative frequency of the class just preceding our median class. And F is simply the frequency of the median class itself. Very logical, is it not?
Section 2. Solving for the median, applying our knowledge to real data.
It is time to look at a practical, solved example directly from our textbook to show exactly how these steps work in action. Take a good look at this table showing the ages of museum visitors. Sometimes the exam question gives you a cumulative less than table to begin with. Notice how it says less than 10, less than 20, and so on. We have to use our logic to decide the true class limits first. Since the age of any person is always positive, less than 10 naturally becomes the class 0 to 10. The next becomes 10 to 20. Then we must extract the actual frequencies class by subtracting. For example, the 10 to 20 class frequency is 10 minus 3, which gives us 7.
Let us move to the next step and see how this builds up perfectly. Our total frequency n is 71, so n divided by 2 is 35.5. Now where does 35.5 sit? It falls into the cumulative frequency of 40, which means our medium class is 30 to 40. Now for the final execution. We plug our numbers into the formula. L is 30, CF is 22, F is 18, and H is 10. Doing the simple math inside the brackets first, we discover that the median age of the museum visitors is exactly 37.5 years. Wonderful.
Section 3. Understanding the mode formula. Finding the most frequent score. We are shifting our focus now to the second major part of our explainer, the mode. I want to remind everyone that while the median was all about finding the middle, the mode is all about finding the single value that repeats the maximum number of times. Let us ground this mathematical concept in a practical, real-world scenario. Why do we even care about the mode? Well, imagine a company that manufactures bicycles of different colors.
To know which color is most loved by the public, the manufacturer desperately needs to calculate the mode. It tells them exactly which item sells the most, so they know exactly what to produce more of. Now here is the formal formula for estimating the mode of grouped data. I fully acknowledge that looking at L plus a big fraction with F1, F0, and F2 looks quite heavy on the eyes. But remember our approach from the median. This is simply just another recipe waiting for our carefully chosen ingredients. The absolute key to mastering the mode formula is visually anchoring and clearly distinguishing between three specific frequencies. F1 is the frequency of the modal class itself, that is, the highest number you can find. F0 is the frequency of the class preceding it, and F2 is the frequency of the class succeeding it. Confusing these three variables is the most common mistake students make during exams. Just remember the simple number order, 0, 1, 2, preceding, actual, succeeding. Section 4. Solving for the mode. Putting the formula to the test. Let us move forward into our solved examples to see how smoothly this new formula works when we rigorously follow our structured steps. Step by step, let us look at this classification of children playing on a ground according to their ages. First, we scan the table to locate the highest frequency. There it is, 70. This instantly makes the 10 to 12 age group our modal class. So our F1 is 70. Our preceding F0 is 58, and our succeeding F2 is 42. Our lower limit L is 10, and class interval H is 2. We plug these straightforward ingredients into the formula, apply the basic math, and brilliantly, we find the mode of the ages is 10.6 years.
Let us examine one more example together. This table shows the volume of petrol filled in vehicles. But wait, what do we notice here? The classes are 1 to 3, then 4 to 6. I must remind you to always stay alert. Watch out for that discontinuous class trap once again. We cannot proceed like this. We simply make them continuous first, using our 0.5 rule, giving us 0.5 to 3.5, 3.5 to 6.5, and so on. The highest frequency here is 40, leading us to our modal class. We carefully apply the mode formula, and we arrive at 4.55 liters. Excellent work.
Section 5. Time for your practice. Your turn to excel. You have done a truly fantastic job following along with these complex topics today. You are now fully equipped with the knowledge and the structural understanding to tackle the practice sets completely by yourselves. Here is practice set 6.3. Notice the diverse practice problems available to you. You have tables regarding milk fat content measured by electrometer, electricity usage by families, and ages of hospital patients. Please remember, mathematics is a skill where consistent practice builds unbreakable confidence. Follow the simple recipes we discussed today, check your steps, and you will do absolutely great. To conclude our explainer today, I want to leave you with a challenge. Take these formulas out of the textbook and apply them to the real world right around you. How would you collect data and find the modal shirt size of your own classmates, or the median height of the students sitting right next to you right now? Think about how you would arrange that frequency distribution. Math is everywhere. Keep observing, keep practicing, and thank you so much for learning with me today.